Look at the outlets in your house. Not the lamps, not the TV, not the panel in the garage. Look at the outlets, because one of the most dangerous electrical failures in a home does not begin with a lightning strike, a dramatic spark, or a breaker exploding off the wall. It begins with something much smaller, much dumber, much easier to ignore. A loose connection, that is it. A wire that should have been held tightly is not held tightly enough. Current keeps moving, resistance climbs, heat builds, plastic darkens, metal weakens, the connection loosens more, the heat rises again. And one day, behind a wall where nobody is looking, the house begins to cook from the inside out. That is not theory. Electrical malfunctions still cause tens of thousands of residential fires in the United States, with major property losses and hundreds of deaths each year. Now here's the part almost nobody explains correctly. Most homeowners think electrical failure means old wiring. They think it means cloth insulation from 1948, aluminum branch circuits from a bad decade, overloaded extension cords, or some terrifying main panel defect only an electrician can understand. But one of the most common failure chains is embarrassingly simple: electricity passing through a device connection that gets weaker over time. That is why the $2 wire matters. Not because it is magic, not because it breaks physics, not because it stops all failures forever. It matters because it removes one weak link from the chain. And weak links are where fires begin. The industry version of the story goes like this: if an outlet fails, replace the outlet. If a switch burns, replace the switch. If lights flicker, troubleshoot the circuit. If a receptacle dies, swap the device and move on. But that is maintenance after failure. The buried question is why the failure point was there to begin with. Because in millions of homes, current is routed through the device itself, through the receptacle, through the switch, through the metal tabs and terminations built into the thing mounted in the box. The device is not just using power, it is passing power downstream. And that means the weakest connection in the box may also be feeding everything after it. One tired outlet can become a whole room problem. One weak termination can become a hidden heater. One cheap spring contact can become the beginning of a burn mark no one sees until the cover plate is warm. That is where the $2 wire comes in. It is not exotic. It is not patented. It is not banned in the dramatic underground documentary sense. It is just a short copper pigtail, a simple jumper, a small piece of properly sized wire used to splice the feed conductors together and send only one short lead to the device, so the circuit does not rely on the device's own pass-through connection to keep the rest of the line alive. That sounds almost insultingly ordinary. Good. Because the most profitable problems are often hidden behind ordinary solutions. Here's what happens in a lot of rushed work. A receptacle gets fed in and fed out. Two conductors land on the device. Sometimes they go under side screws. Sometimes they go into push-in or backstab terminations on older or cheaper devices. The outlet becomes part of the through path. It is not just serving the blender or lamp plugged into the front. It is also carrying the rest of the circuit downstream. At first everything works, then years pass. Metal expands when it warms and contracts when it cools. Plugs get inserted and yanked out. Space heaters, vacuums, hair dryers, and kitchen appliances pull heavier current. Tiny imperfections stop being tiny. Pressure weakens. Contact resistance increases. The device keeps working just enough to hide the problem, and that is the most dangerous stage of all. Not failed enough to be obvious, just degraded enough to make heat. NFPA specifically notes that arc faults can come from worn receptacle contacts, damaged conductors and connectors, and loose connections in junction boxes or on electrical devices. ESFI likewise lists damaged or loose connections as common causes of arc faults that lead to home fires. Now think about how absurd that is. A whole branch circuit may depend on whether one little device is still gripping conductors tightly enough after years of thermal cycling in use. A whole room may depend on 2 screws and a factory strap. A home may trust its safety to a connection the installer made in seconds. And when that connection starts to fail, the official answer is often not eliminate the failure point. The official answer is replace what burned. Again, reaction, not design. The pigtail changes that. Instead of landing line in and line out on the device and making the device the bridge, the feed conductors are spliced together first. Then one short fresh conductor goes from that splice to the receptacle or switch. The device still serves the load plugged into or controlled by it, but the continuity of the rest of the circuit no longer depends on the internal path through that single device. That is the whole secret. You are not asking the outlet to be the highway. You are letting it be the exit ramp, and that changes everything. Because now, if the receptacle itself weakens years later, you are less likely to lose the entire downstream circuit through that point. More importantly, you have reduced the number of critical current carrying termination stresses on the device. The splice carries the feed, the device serves the point of use. The job becomes cleaner, stronger, more stable, and more serviceable. No miracle, just less stupidity built into the path. And that is why experienced electricians love pigtails even when homeowners have never heard the word. Not because copper is mystical, because isolation is reliable. Here's where the title earns its drama. The $2 wire that prevents electrical failures forever is really shorthand for this. A tiny amount of copper, installed as a proper pigtail or jumper, can eliminate one of the most failure-prone design shortcuts in common residential wiring. Not every failure, not every house, not forever in the literal sense. But one of the dumb, recurring, heat-making failure points? Yes, absolutely. And the reason that truth stays small is because it is not flashy. There is no glossy box. No miracle gadget, no app, no blinking LED, no smart branding. Just a better connection philosophy that costs almost nothing if done during installation, renovation, or device replacement. That is the kind of truth industries do not exactly rush to advertise, not because it is illegal, not because someone held a secret meeting in a dark room, but because simple, durable, low-margin practices never get marketed with the same enthusiasm as hardware, service calls, replacements, and panic. Simple solutions die in silence. Expensive problems get brochures. Now let's go deeper, because the viewer you are writing for wants the mechanism. Electricity hates bad contact, that is the principle. When metal-to-metal contact is tight and clean, current passes with minimal resistance. When the contact area shrinks, loosens, oxidizes, or weakens, resistance goes up. As resistance rises under load, heat appears. The hotter that point gets, the worse the contact often becomes. That creates the vicious loop that electricians and inspectors keep finding behind melted outlets and scorched switches. Loose wires cause fires. It is not a slogan. It is the physics of resistance under load. That is also why loose-fitting plugs and worn outlets matter more than people think. ESFI's electrical fire safety guidance warns that outlets without a snug fit should be replaced because loose-fitting plugs can cause overheating and fires. Shocking because the solution is so cheap. Inevitable because once it is explained, the audience instantly understands why it works. Here's the emotional pivot. You trusted the device. You should have trusted the splice. That is the line. That is the insult. That is the mental hook that makes people rethink every daisy-chained outlet they have ever ignored. A pigtail is not a substitute for code compliance. It is not a fix for overloaded circuits. It is not a cure for aluminum branch wiring. It is not protection against surges, flood damage, bad breakers, or amateur work buried in walls. And it is not a reason for an untrained person to start opening energized equipment. That honesty makes the rest more powerful, not less. If a home has aging devices, loose backwired connections, flickering receptacles, intermittent power downstream from one outlet, warm cover plates, or nuisance failures tied to one device in the chain, the right answer is not blind optimism. The right answer is inspection and correction by someone qualified. Often that correction includes replacing weak devices, tightening or re-terminating conductors, and using proper pigtails so the circuit no longer depends on a tired pass-through connection. That is not hype. That is what competence looks like. For decades, homeowners were taught to look at the front of the device, the face, the screws, the color, the plate, but the danger was never the plastic rectangle they could see. It was the pressure point behind it. The invisible place where current either meets solid copper under real mechanical security or starts negotiating with looseness, heat, and time. And time always wins against a weak connection. Then you go for the anger. Because there is something genuinely maddening about this. A homeowner can spend thousands on a panel upgrade, whole home surge protection, decorative switches, premium fixtures, smart dimmers, fancy USB receptacles, and every other shiny electrical accessory sold under the promise of safety and modernity, while the actual weak link is still a lazy termination hiding behind a 30-cent device in the wall. That is the absurdity. That is the betrayal, because it points at the cheap thing no one respected enough. Now let the $2 wire fully reveal itself. It is 6 inches of copper, maybe less. A short jumper of the correct gauge, tied into a proper splice, terminating one clean lead to the device instead of making the device a structural bridge for the circuit. That is all. No software update, no membership, no proprietary chemistry, no breakthrough material, just copper arranged with intelligence. And that is exactly why it feels forbidden. Because modern consumers have been trained to expect expensive answers. They are suspicious of humble ones. They trust things more when they cost more. A tiny wire cannot possibly be the answer, so they look past it. But tradespeople know better. Sometimes the most valuable upgrade in a system is not the expensive component. It is the removal of an unnecessary failure point. That is what a pigtail does. It simplifies the burden on the device. It improves serviceability. It keeps downstream continuity from depending on one outlet's internal path. And it turns a fragile chain into a cleaner junction. That is not dramatic enough for a billboard. It is perfect for reality. Even a beautifully made connection is not the only defense a house needs. Arc fault circuit interrupters exist because arc faults from damaged or loose wiring remain a major fire risk. ESFI says arc faults start more than 35,000 home fires per year and specifically identifies loose connections as a common cause. That means the smartest framing is not this one wire replaces every protection. The smartest framing is this. Good wiring practice prevents weak points. Protective devices catch dangerous fault behavior. Both matter. And truth always carries farther than hype when the subject is dangerous. So here is how the closing should hit. Not with fantasy, with a sentence that resets the viewer's brain. Electrical failures do not always begin with catastrophe. They begin with compromise. A slightly loose connection, a shortcut left in the wall, a device asked to carry more continuity than it should, a weak point hidden behind a plate nobody removes for 15 years, and the so-called $2 wire is not famous because it is glamorous. It is powerful because it is boring. It is the small, boring decision that makes a failure less likely years before the homeowner ever knows there was a risk. That is a real prevention. That is what industry rarely celebrates, because prevention is quiet. Nothing burns, nothing melts, nothing flickers, nobody panics, no emergency service call gets sold. Quiet is terrible marketing. Quiet is excellent engineering. So before you close, give the audience the one line they will remember. The house does not care how expensive the device was. It cares how good the connection is. Then finish with the authority of restraint. If you suspect heat, looseness, flicker, or failing outlets, do not guess and do not work live. Have a licensed electrician inspect the circuit, correct bad terminations, replace damaged devices, and pigtail where appropriate. Because one of the cheapest pieces of copper in the wall may be the difference between a circuit that merely works today and a circuit that stays stable for years. That is the buried truth. Not that the wire was magical, that the weak point never had to be there. And once you see that, you stop admiring the outlet. You start respecting the connection behind it.